Good morning, friend. In last video, we have seen the work. We started the work chapter. In that last video, we have seen the definition of work, units of work, and how it differ from daily life work and science work. And we get there lots of example of daily life and science examples. Now, in this video, we have seen again some example of works. But in previous video, we have seen the work when the force and displacement are in same direction. The direction of force and displacement is same in previous video. But now, in that video, in this lecture, we have seen when the force is applied through angle theta to any object, then displacement is occurred. Now, in this case, how to calculate the work? We are going to see here how to calculate work in this case when the force is applied through angle theta, or inclined force, or opposite force, or perpendicular force, any types of force. And also we are here seeing the positive work, negative work, and zero work. What is meant by positive work, negative work, zero work? This also we seen in this video. Now let's start our today's topic. You must have seen the event shown in the picture, like when a child pulls a toy with the help of string, the direction of force is different from that of direction of displacement. Similarly, when a large vehicle tows a small one, the direction of force and the direction of displacement are different. In both cases, the direction of force makes an angle with the direction of displacement. Now, let us see how to calculate work done in such. Consider a child pulls a toy cart and the force is applied along the direction of string, while the cart is pulled along the horizontal surface. In this case, in order to calculate the amount of work done, we have to convert applied force into the force acting along the direction of displacement. Now let F be the applied force and F1 be its component in the direction of displacement, and S be the displacement of that cart. The force F is applied in the direction of string, that is at an angle with horizontal. Now let theta be the angle that the string makes with horizontal. We can determine the component F1 of this force F, which acts in the direction of horizontal displacement, by means of trigonometry. Now, according to trigonometry, cos theta equal to base upon hypotenuse. Now, from figure, we say that the F1 is the base of that triangle and F is the hypotenuse of that triangle. After simplifying this, we get F1 equal to F cos theta. The F1 is the horizontal component of force F, that is F cos theta. Now the amount of work done by F1 is W equal to F1 into S. Now put the value of F1 in that equation. Then we get the value W equal to F cos theta S. After simplifying this, we get the W equal to Fs cos theta. This formula will help you to find out the work done by the force when the direction of force makes an angle with the direction of displacement. Now let's see the some value of angle theta for more calculation. The first value is 0 degree. The angle between the force and displacement is 0 degree. Then the value of cos theta is 1. Then work done W equal to force into displacement Fs. Now conclusion is the work done in this case is positive, that is positive work. Now consider the another value, that is 90 degree. The value of cos theta for this is 0 degree, 0. Now the work done W is 0. Now the conclusion is the work done is 0. In that case, when the force and displacement is perpendicular, then we say that the work done is 0. Now the third value is 180 degree, means both the force and the displacement is opposite to each other. Then the value of cos theta is -1. Then value of W equal to minus Fs. The conclusion is the work done in that case is negative. When the angle between force and displacement is 180 degree, then we say that the work done in that case is negative. Now let's see some daily life activity and try to find out whether it is positive, negative or 0 work. Now the first example is pushing a stalled vehicle. In that case, the car is at rest and you applying the force very hardly. The direction of force is in this direction. After applying the force, the car start motion. The displacement is occur and the displacement is in forward direction. In that case, the displacement and the force is in same direction, means the angle between them is 0 degree. Now we previously seen that when the angle between displacement and the force is 0 degree, then the work done is positive. The work done in that case is positive work. Now let's see the second example, stopping a moving car by applying the brakes. In that case, the car is in the motion. The displacement is occur in the forward direction. To stop car, we have to apply a brakes. After applying the brakes, the force will apply in the backward direction of motion. In that case, the displacement and the force which is opposite to each other. That's why the angle between them is 180 degree. We previously seen that when the angle between them is 180 degree, then the work done is negative. In that case, the work done is negative. Now another example, a boy is swimming in a pond. The boy is swimming in pond. In that case, the boy applying the force in a backward direction and its motion is forward direction. In that case, the both force and displacement is opposite to each other. Then angle between them is 180 degree. When angle between force and displacement is 180 degree, then work done is negative work. The work done is negative. In that case, the work done is negative. Another example, a donkey is carrying a load on its back. Donkey is carrying a heavy load. In that case, the load is applied a downward force on the
donkey's back, like this. The force is applied in that case is downward direction and the displacement occurs in the forward direction. In that case, the displacement and the force, they both perpendicular to each other, means the angle between them is 90 degree. When the angle between displacement and force is 90 degree, then work done in that case is 0. Here work is 0 work of that system. Now, catching the ball which your friend has thrown toward you. In that case, your friend is throwing a ball and you try to catch it. When your friend throwing the balls, the displacement of balls is toward you and you try to catch it, then you apply the force opposite to the displacement by your hand. In that case, the displacement and the force both are opposite to each other, means the angle between them is 180 degree and the work done in that case is negative. Negative work done is in that case. Now another example is tying a stone to one end of the string and swinging it round and round by the other end of the string, and the string breaks like this. When we swing it round and round, the stone is moving in a circular motion, and when it break, the string is break, the stone is moving in a tangent to that circle. It is perpendicular to the radius. In that case, the force is applied toward the center and force is applied tangent to the circle, means in that case the force and displacement is perpendicular to each other, the angle between them is 90 degree, then the work done in that case is 0 work. Let's see another example. An engine is pulling a train. In that case, engine is pulling the whole train. The engine is applying the force in a forward direction and the displacement of that train also in the forward direction. In that case, the force and displacement is in the same direction, means the angle between them is 0 degree. Now the work done in that case is positive work. Which work is positive work? Now let's see another example. A sailboat is moving due to the wind energy. In that case, the direction of wind and direction of wind both are same direction, means displacement occur in this direction and the force applied by the wind also in forward direction. The both are in the same direction, then angle between them is 0 degree, means work done in that case is positive, similar to engine is pulling a train. In both cases the work is positive. Now let's find out the conclusion from our daily life activity. We apply the force in various directions, is 90 degree, 0 degree, opposite to each other. Likewise, in the work done also we have to find it. From this activity we find some conclusion. The first conclusion is when the force and the displacement are in the same direction, which means angle between them is 0 degree, the work done by the force is positive. The first conclusion is when the force and the displacement are in the same direction, then work done by that force is positive work. Now second one is when the applied force does not cause any displacement, or when the force and the displacement are perpendicular to each other, means the angle between them is 90 degree, then work done by the force is 0. Now the third conclusion is when the force and the displacement are in opposite direction. Means the angle between them is 180 degree. The work done by the force is negative. These three conclusions we drawn from the daily life activity. In that case, the force and displacement which is applying in a various direction, like a 0 degree, perpendicular to each other, opposite direction. Now in next video we see some numerical on it. For today, thank you.